Hi, everyone, and welcome to AstroNights Live. Once again, we have a fascinating presentation planned for you, and we're very excited that you chose to spend a little bit of your time with us tonight. Our presentation will be about 20 minutes in length, after which we'll be able to address a few of your questions. Those of you participating on Zoom can post a question via the Q&A window. Be sure to hold your question until the end because it might just get answered during the presentation itself. If you're joining us via YouTube Live, you should know that Q&A is not available, so just sit back and enjoy. Whether you're joining us on Zoom or YouTube, we recommend taking a moment to locate the full screen mode on your app for the best AstroNights Live viewing experience. All of the websites and resources we'll be discussing during our program are available on our website. So don't worry about rushing to write them down. Just relax and enjoy the program. The links will be waiting for you whenever you're ready. You'll be invited to complete an online survey at the close of the program, and we hope that you'll take a moment to share your thoughts with us. Your feedback helps us in planning a future AstroNights Live events. And now I would like to introduce you to our presenter, Mary McDonald. Mary is the Planetarium Programs Manager at the FSU Planetarium, and I know she's anxious to get started. Mary?
Thank you very much, John. Everyone, welcome to AstroNights. My camera hasn't been behaving, so I'm probably going to turn it off pretty much right away. But I did just want to say hello to everyone and welcome. So we're going to start tonight, as we often do, with a little question to get the ball rolling. So let me bring that up. Here is tonight's question. And here goes my video, taking that away. So the question is, where in the solar system besides Earth are you most likely to find lots of water? Now, whether you're watching on YouTube or you're on the Zoom, everyone who's participating in AstroNights together as a group, I'd really like you to turn to each other and talk about this question and ask each other. But for those of you that are in Zoom, I am also going to share this through a poll. So everybody should be just talking a bit about the question. And now I am going to share the poll. Go ahead and put in your answers. Okay, let's take 10 more seconds. Where in the solar system besides Earth are you most likely to find lots of water? And I am going to end the polling. So, what answers do we have from our audience? Let's quickly share the results. A lot of people said Saturn and its moons, but we also got responses for Mars, Jupiter, and for beyond. So many of you may have perhaps wanted to choose more than one. I was just kind of curious to see which one would come out on top. But this is another one of those questions that doesn't really have a right answer. I love those. In fact, a lot of questions are like that. So I would say there is at least one answer here that is pretty much not right. And that would be Number 1, Venus. So Venus used to have a lot of water, at least there's evidence to suggest that. But because it is so close to the sun and so hot, almost all of the water on that planet has evaporated into space. Now, the next one on the list, Mars and its moons. Well, we certainly do hear a lot of discussion about water on Mars, and there definitely is water on Mars, but almost all of it is frozen. And that's not quite as interesting to us for a few reasons, although it is interesting. So liquid water on Mars, it's still kind of an unknown. There's still a lot of exploration that needs to be done to really get answers about how much liquid water there is on Mars and where it is, and whether it could be accessed. But the rest of the answers, Jupiter and its moons, Saturn and its moons, and beyond, those are all great answers. And all of those indeed are places where quite a lot of water can be found. So that's kind of a theme that's going to come up a little bit tonight in a couple of our discussions. So if you picked really any of these answers, you're on the right track. But I think you're going to learn that there's more water out there than you might have imagined. So we usually turn at this point to our night sky, but tonight we're going to go straight to outer space. So let's start with a view of our solar system. And you can see that our solar system has a guest that's not always found there, but certainly is today. And hopefully you have guessed that that is Comet Neowise, which has been in the news quite a bit recently. If you joined us for the last AstroNights, we talked a bit about Comet Neowise, and you can see that video on our YouTube channel. We'll talk more about where you can find those at the end of the program. But we'll talk a little bit more about it tonight because the comet is, as you can see, still within our inner solar system, and it is still technically visible in the sky. So we had an important moment that occurred in the comet's journey recently, which was that it reached its point just yesterday when it was the closest it is going to be to Earth. Okay, you should be seeing Okay, I wanted to show you the date, but that's not showing. Oh, hold on. I think I can fix this. Okay, you can see the date. There we go. So this is today's date, and you can see that the comet is pretty close to Earth. Let's go back in time a little bit and watch its journey in the last couple of days. So the comet first became visible to telescopes back in March, and after that, it began its journey towards the sun to get really in close towards the sun. It reached what we would call perihelion, which means the time when it is closest to the sun, around July 6th. So you can see that at that time it was really close to the sun. And the software here is showing you should have noticed that the tail gets longer and brighter as it gets close to the sun, because the tail is really due to the ice that makes up the comet evaporating and dragging this tail of evaporating ice and also dust into space. So the closer it gets to the sun, the more of that evaporation is occurring, and the more you're going to see of the tail. So this was its closest point to the sun around July 6th. And then, as I mentioned, hopefully I didn't just mess something up. As I mentioned, just yesterday, actually, the 23rd of July, it reached its closest approach to Earth. Now, you may take a look at a headline. It may say comet approaching Earth, might make you feel a little bit nervous, but hopefully this view of our solar system shows you that it is really not very close to Earth at all. So if you're not worried about the planet Venus being too close to Earth, then you really shouldn't be worried about comet Neowise. Or for example, if you're not too worried about the moon being close to Earth, which you can't even see the moon in this view, it's pretty much right on top of the Earth compared to comet Neowise. So yes, it is coming as close as it's going to come to Earth, but it's really not very close at all. So take a moment and ask yourself, is there anything else interesting you notice about the comet, its path in space, the journey that it's taking right now? There's really a lot to unpack here. What do you notice that's interesting about it? One of the things that really jumps out to me is the orbital path looking so different from the planets. So the planets' orbits are almost perfect circles. I mean, they're not perfect circles, but they're pretty close. The comet's path is much, much different. It's what we call elliptical, which means that at one part of its orbit, it gets really close to the sun, but at the other end of its orbit, it's really, really far away from the sun. So I'm actually going to zoom out a little bit so you can see really more what that path looks like. So because its orbital path is so long and extended, it takes a long time to get back to the sun. So this is a comet that's known as a long period comet because its orbital period is really long. This one is expected to be about 6,700 years. So it'll be about that long before it comes back to the sun. So in this view, there's something else I want to point out this evening. This is the other thing we were going to talk about tonight, which is the planet Saturn and also actually the planet Jupiter. So you might notice that, let's leave Earth labeled. You might notice that the planets Earth, Jupiter, and Saturn are kind of lined up nicely. And they are indeed. This is a particular arrangement of these planets. I'm going to show you in a little bit of a nicer way. That's known as opposition. And this is the best time to observe these planets. So opposition occurs when Earth, I should have my my arrow going. Here we go. When Earth and these superior planets, the ones that are far away, are on the same side of the sun. And this is the best time to observe these planets because think about us on Earth. During the day, we're facing this way towards the sun, but during the night, we're facing this way away from the sun, which means in our nighttime sky, we have really great view of the two planets, Jupiter and Saturn. And also, they are going to be fully illuminated by the sun. You know, think about, compare to the situation that would occur if Jupiter was over here. We might not see it fully illuminated. But right now we're seeing it fully illuminated, so it's at its brightest that it's going to be in the sky. Just to show you sort of the opposite of this, let's take a look at what the arrangement of the planets is going to be a couple months later, about 6 months later in January. So look at the date up here. This is January. And this is basically the opposite situation. This is called conjunction. Conjunction sounds like it should be good, but it's actually not a good time to observe the planets because, again, think about this time. During the daytime, we're going to be looking from Earth in this direction. So basically, the planets are going to be in the sky during daytime, which means we can't see them too well or at all. And then at nighttime, we're looking this way, and we have no planets visible. So let's go back to opposition real quick, which is what's going on now. Obviously, there's one particular moment in the orbital paths that represents opposition. And Jupiter reached its opposition on July 14th, and Saturn just reached its opposition on the 20th of July. So both of them happened really recently, which means both of them are still very, very bright and visible in the night sky. And then the last thing I want to point out here is, again, we're going to go 6 months forward to the conjunction period. And you might notice that Jupiter and Saturn haven't really moved that much. The outer planets move much slower in their orbit. So it really is kind of controlled by Earth's motion. Earth is moving much faster. So these two planets are essentially in relatively the same part of the sky, but it's Earth that is now on the opposite side of the sun from them. All right, so what does this mean for our night sky? Well, now let's finally go back to Earth and take a look at what we can see this evening. This is your sky tonight at about 8 p.m. And you can see that the sun is setting and we are getting a lovely view of a crescent moon. Let's let the sun go down. The reports are saying that if you want to try to observe comet Neowise in your sky, you should wait till at least an hour and a half after sunset. So that's going to take us to about 9:45 in the evening. The reason for that is because a comet is relatively dim, so you do need the sky to be pretty dark to be able to see it. Now, the comet is not visible right now in the direction we're looking. We need to turn, and luckily for us, the comet is really close right now to a very familiar pattern in the night sky, the Big Dipper. So if you have joined us for previous AstroNights, you probably can help your friends that are with you try to guess where we should look in the sky to see the Big Dipper. So right now we're kind of facing towards the southwest. So to locate the Big Dipper in the sky, we need to turn what direction? That's right, everyone. We need to turn north. So that's what we're going to do. We're going to turn towards the north and let me know whether you can see the Big Dipper in your sky. So have a look around and see if you can find that familiar shape. Did the stars just get a little bit brighter? Crazy. Yes, that did happen. If only we could do that in the real sky. Anyway, if you think you have found the Big Dipper, let's find out if you have spotted it. It's not directly in the north. It's a little bit more towards the northwest. And there it is, the 7 stars of the Big Dipper. So we've discussed how the Big Dipper has the handle and then the scoop part here. You want to kind of look towards the scoop and kind of go, I think in the past, maybe we've explained how to find the North Star, which is to take the last 2 stars in the scoop and follow the line this way. And there's the North Star right there. If you follow it the other way, this is the area you're going to be looking for the comet. So what I did just a few days ago, and I live extremely close to Boston. I do not have dark skies, and I was able to see this comet. So I took my binoculars, and again, not a fancy pair of binoculars, just sort of your average everyday pair. And I just sort of scanned the sky in this region, and I did indeed see it. And are you ready to see exactly what the comet does not look like? Okay, this is not what the comet's going to look like. That. I mean, in general, it looks like that, but it's not going to be this bright. This is just sort of the standard animation of the comet. But this is doing a really good job of showing you sort of where it's going to be in the sky. Now, it was still visible a couple of days ago. We've had a lot of rain, so I haven't been able to check on it. But allegedly, it should still be visible for a couple more days. Oh, that should be showing you the date, but it's not really doing that. So this is showing you where it's going to be in the next couple of days. So this is the 30th here, and into August. Okay, so as you can see, it's changing its position with respect to the Big Dipper. And you might also notice that it's getting dimmer. That is a prediction, but we really don't actually know how bright or dim it's going to be. That's just a guess, really. Comets are really unpredictable. Anyway, let's go back to today's date. And I hope you all have good luck trying to find it. But now we want to talk about the other thing in our sky that we wanted to observe. So we're going to turn back towards the south. And the same night I went out and got some great views of Comet Neowise with binoculars. With just my own 2 eyes, there was lots of other beautiful things to see. So right here in the south, we have a beautiful view of the constellation Scorpius. I have talked about this in past episodes of AstroNights, as well as the teapot of Sagittarius, both easily visible in the night sky right now. And just beyond the handle of the teapot here, this really bright light here, this is the planet Jupiter. So this is what you really should have no trouble finding. Really, really bright. It just reached its opposition recently. And then just to the left of it, we also have the planet Saturn, which also just reached its opposition. So they are super, super easy to spot with the naked eye. Also easy to observe with a telescope, even a small telescope. But here at AstroNights, we're going to go one step further. And tonight, we are actually going to go ahead and visit Saturn. So just try to ask yourself what you think it's going to look like to visit Saturn. What are we going to see? What do you know about this planet? What might it look like from space? And there it is. I think that probably everyone was able to, make the prediction that we were going to see these beautiful rings, because this is probably the most well-known feature of Saturn. The rings have been known about since the very first time Saturn was observed with a telescope. The planet Saturn has been known since the beginning of human history, but the rings weren't really known about until Galileo observed the planet with his telescope. Now, because his telescope was very low in resolution, he was not able to really figure out what was going on. He just knew that there was something on the side of the planet, and he referred to it as a planet with ears, or he thought they might have been moons. But later, it was observed that once telescopes got better in resolution, it was observed that this is a ring system. So really, really lovely. Saturn does actually have moons. So I'm going to point out some of them here. Last time on AstroNights, the trivia question was, which planet in the solar system has the most moons? And the correct answer was actually Saturn. Saturn has the most known moons in the solar system. Ooh, oops, we're leaving Saturn. I was trying to locate its moon Titan, and there it is over there. So yeah, Saturn has 82 known moons. There are no doubt more moons that are not known yet, because it is just a very complex system. One of its moons, Titan, is one of the largest moons in the solar system, and the rest of the moons are very interesting as well. So we talked a bit about which place in the solar system are we most likely to find a lot of water, and Saturn and its moons is certainly one of those places. So the moon Enceladus, which is a relatively small moon here, is one of the most interesting places in the solar system. So the surface is almost entirely made of ice, but just like Jupiter's moon Europa that we talked about last AstroNights, excuse me, the ice is cracked and wrinkled, and we know pretty much for certain that there is a liquid water ocean underneath. So it's not frozen solid, it's liquid in the layers underneath and very, very deep. And it's not just because of the cracks that we know that. A spacecraft visited Saturn. Some of you may have heard of it. It was called the Cassini spacecraft. It spent 13 years exploring Saturn and its moons. And one of the coolest things that it did was it actually flew past Enceladus. And it found that it has these crazy cryovolcanoes where material from under the surface are spewing out into space. And Cassini was able to take samples of what was spewing out and did confirm that it was in fact water. So this is really one of the largest sources of liquid water in the entire solar system. Titan, which we talked about just a moment ago. Let's see if we can get Titan in view again. Titan has a really is really distant from Saturn. So Titan, as I said, is one of the largest moons in the solar system. And this is another very, very interesting moon. It is compared to Earth a lot of the time because it is the only known place in the entire solar system besides Earth that has liquid on its surface. So I'm going to show you an image that shows those. So I don't know if you can see that well, but this is a real image from the surface of Titan. And you see those blue colored areas at the North Pole there. Those are lakes that were photographed by Cassini and by a probe that actually landed on Titan. Now they are liquid, and this is the only place in the solar system where liquid is found in permanent bodies on the surface besides Earth. But this is not water. This is liquid methane. So it's similar to Earth in that it has liquid on the surface, but it's not water. However, we do also know that under the surface, there is a liquid ocean, similar to what you find on Enceladus. So Titan may actually be one of the largest sources of water in the solar system as well. And the important thing to recognize here is that in both of these cases, we're talking about liquid water. And that's what's really, really important in our exploration of the solar system is liquid water, because the reason why water is such an important part of our exploration of space is because here on Earth, we've pretty much figured out that water is essential for life. So wherever we know there is liquid water out there, that's the places where we want to really focus our search for extraterrestrial life. So that's a quick little introduction to our lovely Saturn. I think you don't often get an opportunity to travel to Saturn. And at this point, I'm going to turn it over to your questions because I'm sure you have plenty. So if you have a question, you can put it in the Q&A window. And once again, this is only for our guests on Zoom. If you are joining us on YouTube, I really do encourage you to join the Zoom webinars because that does allow you to put your questions in and also participate in the polls. All right, so I'm going to give you just a moment to enter your questions, and I will get to them, everybody. And while we're waiting for people to enter them, I'm going to really quickly just remind everyone about our website. So this was shared at the beginning. John shared the URL. So our main website is cm-center.org for Krista McAuliffe Center, which is where the FSU Planetarium has its physical home. And we put everything that's really useful to you right here on the front page. All of the programs that are being brought to you by the FSU Planetarium are listed under From the Dome to Your Home. And I just wanted to show you all that there's a section for AstroNights. And each program has its own event page. So you can see all of the past events. If you missed any of them, the links to the recordings are available there. And if you go to tonight's show page, this is where you're going to find a lot of resources. So we've had a lot to say about Comet Neowise and Saturn, and I'm definitely not going to be able to answer every question that you might have, especially about Saturn. But I have some really great resources there that I recommend you check out. And finally, you will find in several noticeable locations an opportunity to donate to our center, just like many, we would really appreciate that. All right, so I'm going to go back to Saturn, and I'm going to start taking a look at your questions. All right, let's take a look at the Q&A window. Okay. Okay, question from Olivia. How many rings does Saturn have? Okay, that's a good question. And another one of those questions that does not really have a correct answer, at least not one particular correct answer. Let's get a little bit closer. So first of all, if anyone likes to guess what my backgrounds are, this is a super, super high resolution image of Saturn's rings as captured by Cassini. And maybe in this image behind me, you can really see that it appears like there's many, many rings. It's, you know, Galileo and later scientists probably really thought it was like one solid ring system, like a frisbee, but it's actually millions, billions probably of tiny, tiny particles that orbit around Saturn. So it's made up of really billions of tiny little moons, each one in a little orbit around the planet. So I can't really give you one answer on how many rings there are, but I will tell you that shortly after, or after Galileo's time, not shortly after, but significantly after, it was thought that there were two rings, not one but two. And the rings were named, so this one right here was named the A ring, and this one was named the B ring. So at one point it was thought there were only two. And they were separated by this big gap right here, which is known as the Cassini division, because this was recognized by the Italian/French astronomer Giovanni Cassini. He had a better telescope than Galileo had. It had better resolution. So he was able to see that there was not just one ring, there was two. And then of course, as resolution got better and better, you can see that there's way more than two rings, there's billions. And there's no way to possibly get better resolution than the Cassini spacecraft, which actually visited Saturn and was able to get images up close. So beyond the A ring and the B ring, we now have the D ring and the C ring. So they're kind of like not in order because of the order that they were discovered in. But you know, to break up the whole A ring, you know, we really know it's not one ring at all. It's many. So great question, and as usual leads to more questions. Okay, next question from Nathaniel. What gases make up Saturn? Also a good question, very important question. So Saturn is almost totally made out of hydrogen and helium. So everybody, I'd like you to think about, do you know of anything else in the solar system that is almost totally hydrogen and helium? If you're guessing the sun, you are correct. Yes, so the sun is almost totally hydrogen and helium, and so is Saturn. Compare that to planets like Earth, the rocky planets. They're made of many, many more different types of materials, but Saturn is actually pretty close to just the same material as the sun, hydrogen and helium gas. There are, of course, other gases in there, but it's pretty much 99% hydrogen and helium. And one of the most interesting things I've learned recently about Saturn is that planets like Saturn and Jupiter, they kind of behave more like stars than they do like planets. So because they're essentially just like a star, they're a big ball of hydrogen and helium gas. The only difference is they're smaller and they don't fuse that material in their core. So they don't turn that material into energy. but the way that they rotate, the way that waves move through them, that is much more similar to a star than to a planet like Earth. Okay, and so I'm going to turn to another question, because I said it's mostly hydrogen and helium, but there are a few other gases. And that transitions well to my next question from Linda, which is, what colors does Saturn have? And the answer to that is many colors. You're seeing, the most standard colors being, kind of a yellowish gold, but Saturn actually changes colors. And there's two reasons for that. So before I talk about that, we're going to take a look at the North Pole of Saturn. Now, you can't do this with a telescope, right? We can only see the side of Saturn that's facing us. But if we actually travel to Saturn, then we can see different views of it. So look at that crazy looking North Pole. Let's get a little bit closer. This is one of the most interesting things about this planet, is that its North Pole kind of has this like weird hexagon thing on it. And this is something that's actually been photographed. It's a very strange shape. It's really like a hexagon. You don't usually see straight lines like this on a spherical body, but it makes sense, apparently, if you know a lot about fluid dynamics of large planets that are rotating. This is what you might expect to see. So it's similar to some of the things you see on Jupiter that we describe as vortexes, as basically storms or hurricanes. There's pretty much one going on permanently at Saturn's North Pole. So anyway, I mentioned that Saturn changes colors, and the reason for that is because Saturn has seasons, just like Earth. So any planet that is tilted on its axis is going to have seasons. And Saturn is tilted about 27 degrees. Compare that to Earth being tilted 23.5 degrees. So Saturn has summer and it has winter and spring and fall, just like Earth does. And right now we're actually witnessing the summertime on Saturn. I can't tell you that this view of the planet, of its colors, is totally accurate. You'll have to go to the event page and look at the Hubble Space Telescope image that was taken just recently of the planet. And that's actually something Hubble does every year. It takes a picture of Saturn at opposition each year, and it observes the seasonal changes in the planet. And one of the changes is that here at the North Pole, the colors change. So this might not be what it looks like right now, but mostly in summer, the North Pole is going to look more yellowish gold, and in winter, it actually looks blue. So let me see if I can get a little bit, I can show you some of so this is probably a little bit closer to the summer colors. And that's probably a little bit closer to the winter colors. But in the Hubble images, it's really, really noticeable. So I encourage you to check those out. Now, really quick, why does this happen? It's because in the summertime, the North Pole is getting more sun, and that's going to cause some of the gases to evaporate. And in winter, those gases are going to be able to stick around there longer. And it's really those other gases besides hydrogen and helium that are contributing to the color. So hydrogen and helium are pretty much always there, but the seasons are going to change the concentrations of the other gases, and that's going to lead to different colors. Let's go back to that other regular one. Okay, so great question from Linda about the colors. Okay, next question from Shiba. Does Saturn have a rocky core? So great question about the core. Obviously, that's something that we can't necessarily see. We have these really thick layers of gaseous atmosphere that we cannot see through. And you also can't really send a spacecraft down there to look at them. You might think a spacecraft could just fly right through the gaseous layers, but the gas is so thick and dense that the pressure would actually crush any spacecraft that attempted to do that, which is what we believe probably happened to Cassini. The Cassini spacecraft, after it completed its mission, dove right into Saturn and was never heard from again. So we don't know exactly how long it was able to withstand the pressure, but it's gone now. Anyway, so we can't really directly observe or study the core, but when you orbit the planet and study what you can see, you can use what we know about gravity to try to make inferences about the core. And it's not thought that the core is rocky, it's thought that the core is metal. And what's not really clear is whether the core is solid or liquid or both. So there's still a lot of questions about the core, and it really just comes down to more observations and more theory, because we really have to work out the theories and test them against observations. All right, so that's going to be my last question for the evening. Really great ones, everybody. Once again, I want to remind you to check out our website, because if you have a question about Saturn, I have some wonderful resources there that you will get lost in, and they're just the beautiful images. And most importantly, I hope that you all get some clear skies pretty soon and you can go outside and see the planet yourself, as well as Jupiter and the comet we looked at earlier. All right, so that's going to do it for AstroNights tonight. Thank you so much, everyone, for joining us. We hope you will join us in the future.